Hi, I'm John, or Dad, and welcome back to Dad's Shed. Now, if anyone saw the last video, that involved me resetting the tailstock from turning taper to turning parallel. And the very highly edited video of what was rather a long and drawn out procedure saw me get it to turn parallel over a 7.5 inch length, which is the length of the spindle I'm producing for my new milling head. Now this is the spindle, and the plan was to put it in the 4-jaw chuck at one end because it won't go through, and then support on the centre at the large end with tailstock centre, get it running nice and true there, and then put the fixed steady on at the outboard end. However, two problems with that, or one problem and one solution. One is that there is not an awful lot of length on this bed. It's only an 18 inch between centres, and I will need to bore through 7 inches, which means I haven't got room really to put a large enough drill to drill through, and that was a bit of a pain. But I also realised what I'd forgotten is this has now been turned down quite a lot and will actually fit through the bore of the 4-jaw chuck. So I could grip the 4-jaw chuck there, which only leaves this bit sticking out, and that's not a problem. And if I can get these sections running true, held nice and tight in the 4-jaw, it will be square. So slight change of plan. All I now need to do, is to set up the compound slide and then set up the spindle in the 4-jaw chuck. So that's what I'll be going through in this video. Enjoy. Well, welcome into the shed, and I'm just going to set up now to get the lathe ready to cut the internal taper on the new spindle. So it's an International 30 taper, or 30 NT, or there's a number of other descriptions for it. The taper specification is 3.5 inch per foot, and that works out at 16.98 and change degrees included angle, so just under 8.5 degrees offset on the top slide here. So all I've done is I've set this up in the chuck with centre in there, and I'm just going to run this gauge up and down using the compound slide. So I'll set that round to 0, then I can move that up and down to try and get it to the point where it's effectively giving me no deflection. That's just giving me an absolute shade. Well, according to my dial gauge, that is giving me 0 either end. So that being the case, I'm quite happy with it. What I will do is when I'm boring it out, I'll use one of my Int 30 tools as a gauge. I'll blue it up and check it before I get to the final size, and that way if there are any differences I can make some very fine adjustments to it at the last minute. So that's set up. It's obviously picking up. Unfortunately on these things you tend to get a little bit of movement on the taper where it's been used over the years. So that is now hitting the end there. But that's effectively no movement from one end to the other. So I'm happy with that. So I'll move on and we'll start setting up, ready to actually bore out the spindle. Right, that's within half a thou on that, so I'm quite happy with that as a setup to start drilling through and boring out to take 16 mil. At that point I'm going to have to stop and grab something to eat and then go and fetch children. So thank you very much and I'll see you again shortly. So this has all been checked as running square and parallel. I've already got a centre in here from when I turned it down to its base settings on the external side. So I'm just going to start drilling through. It's got a long way to go. I'm probably going to need to drill from the other end to finish it off. But I'm going to get most of this done this end. And then I'll start doing some of the boring out. And I'll drill out some of the centre so I don't need to bore a huge amount out. So we'll start off with an 8mm drill and see where we go from there. unconventional use of a spanner, I admit, but it works, and it stops me putting my fingers all over the rather warm and fairly sharp swarf. Don't ask me how I know about that, so I'm not going to admit to being really stupid at any point. So that can go back in there. Let's take this back, take that one off, put this one in. This is 25/32ths, 25/30 let's be honest. I'm going to drop the speed down a little bit for this one. I had the edges taken off it a little bit and I haven't had a chance to regrind it. So let's drop that down to about there. As if it will cut without being reground. No, that's a bit of a pain. That's not too bad. I'm not too worried about that because that actually gives me, on 5/8, enough room to get a boring bar down there. So, I'll start doing a little bit of the old boring stuff in a moment. Let's see if I can just stick this. Actually, let's be a vaguely sensible person here, John. Let's bore out a little bit of the end here. Oh, the joy of being able to do this now. That is so much better than the previous method I had to use. Where are we? Are we about centre? No, we're a bit higher actually, aren't we? Should be about right. That's giving a bit more clearance around the back end of the drill. I think I'm going to get on the phone in a little while on the computer motor's point and get a long series 16mm drill bit. That's 4.5 inches in, so that will take me down to there. So I've got another 3 inches to go. I think if I can get a long series drill for that, that will do that quite nicely, and then I won't have to turn it round and drill it from the other end, just cleaning up a little bit. Right, so that's given me a 5/8 through hole. All I need to do now is have a quick look around, find out where I've carefully stored my boring bars. And that looks like a likely prospect. Yes. So I get the boring bars out and just set up and start boring the taper. This is another homemade piece. It's rather long, but it enables me to get down into a job, and I was finding it very difficult to find the tools that I actually wanted to do the work. Yes, I could buy something like that, which is great and does a really nice job. But it's actually very limiting on what you can actually do with it. And that one, obviously I don't need to have it all the way forwards. I can actually adjust it as I need, and it gives me the ability to do work that would be otherwise, let's say, challenging, I think is probably the best description. And one thing I didn't do, and one of the tools I've got to make at some point in the near future, is a tool setter that will sit on the top slide there, on the cross slide rather, to enable me to set tools when I've got work in there. I've got a gauge I can set to, but it sits in the chuck, and obviously that's not exactly the most useful place for it to be when you've got work in there. So that I think is going to be too high, because that's set for the tool post before it was modified. Yeah, that's quite a lot too high. So let's drop that down a bit. One of the things I found with these particular tool posts is that the finish on the adjuster top surface is, I think the word poor is the nicest term I can use. They also vary a bit in thickness, and as you adjust them they tend to catch on this, but also as you tighten up it catches on them. Rather than just locking into place, it tries to pull them down or up, and it's a real pain, I think is the best description. This is one I haven't yet modified with the new through hole, but that's going to be not long in the future, as this system I'm finding, although on the Dixon tool post I've used in the past at work has worked fine, it doesn't work so well on this. turn the compressor on, give yourself some air. And most importantly, have a break for a mouthful of tea. I need to take out a little bit more at that far end. It needs to be over 5/8. So what I can do is take the boring bar down there. And I'll spin that round a little bit. Still can't get my head around the fact I can actually do this so easily now. Right, that is actually not quite sitting as I would like it to. Right, I'm going to come back to that. I'm going to do a bit more checking, because that, although it wasn't giving any contraindication when I dial tested on the taper. He's actually given me a slight rock, and it says the back end is tight but the front is a little wider, so not a problem. That's why I've stopped at this point anyway to check. I've still got another couple of mil to take out. I need to make sure that that is actually cutting at the right taper. So let's go away, do a bit more checking, and I'll come back and we'll start again. Okay, let's see where we go with this. Swapped over to another shop-made tool here, boring bar. Takes a much smaller but sharper tip, and it gives him a nice, much nicer surface finish in there. All that's fitting in, no rock at all. Rock solid, as they say. So I am rather pleased with that. So I'm going to take one more cut, another couple of thou out there, and then I'll take a mild skim off the front. Or shall I? No, I think I'm going to leave that as is, and then I can put in my 2 blocks that will hold that in place. That's nice, happy with that one. Right, so that is my spindle nose done. I'm going to just take a little bit off that edge there to get rid of the sharp edge on it. And then I'll need to then wait for my long series drill to arrive, which will be a couple of days. And I can drill that through to make sure I've got clearance for 2 things. One is the back of my biggest 30-inch tool holder, and make sure I've got the width there for that and the depth, and make sure I've got clearance for the drawbar. So that's going to be the next job, but I am rather pleased with that. That's as good as I expected to get. Great. So that's that bit done. Getting really close now to assembling this thing, and then I'll have a mill that I can do slightly bigger cuts on. So we'll come back to this when I get the drill to finish drilling through. See you in a few minutes. Well, it's arrived. I've managed to get hold of a long series 17mm Morse taper drill bit. It's come off of eBay, and it's from a company that sells reground bits. I've had a good look at it. It looks rather nice. Obviously it's been used in the past, but nicely sharpened. So I'm going to use coolant on this one because it's got to go a fair way through. I'm going to have a look at the speed, and I think I'm going to take this down to about 200. Let's start at 206 RPM, this says. I'll just have a quick look, make sure that is going at the right sort of speed. Yeah, that looks about right to me. So let's start up the coolant, move that through so it's not quite touching at the bottom end. Lock that up tight. This has all been lubricated up, so let's see what happens. We do a bit of drilling. At the moment this is just enlarging the hole that I've already put through. The real test will come when it gets to the bottom of that hole and starts drilling on its own account. But I must say the chips coming off of this are rather nice. So I'm hopeful. Well, you can see I don't use this coolant very much. It's going onto the drill, but not by a great deal. Let's see if that's actually could do with going a little bit quicker. Let's take it up to 330 RPM. Let's back that off a little bit from the end and see where we go from there. One thing you will have noticed is I've put my homemade fixed steady on here. I would have used the original Colchester one, but unfortunately it won't fit over the largest diameter, which is why I made this in the first place. So I can't actually get it on unless I demount everything, which was running nice and true. So I decided to play safe and I'd use the slightly larger one, and all it's there to do is just to make sure that this doesn't move around at all at this end. Okay, so that is through at the far end. but not full diameter. So just take it through a little bit more. Well done that drill. Good purchase off of eBay that was. Wasn't particularly expensive. It's a nicely reed-round long series drill. I'm not going to use it very often, I don't think, but it gives me the ability to drill through on a fairly large piece of stock. So I've now got a 17mm through hole to give clearance for 5/8. The last thing I want to do is to double check the upper diameter of my large collet that will go in there to make sure that I've got enough clearance at the top end for that. I've got a 20mm drill bit here as well, and if necessary I'll drill through with that and then clear it out with a boring bar. But for the present time that is drilled through. The next bit of work, which I will have to use the milling machine for, so this will be put to one side for a little bit, is I need to cut in the end here 2 slots so that I can then manufacture 2 drive blocks to be screwed into place, so that when I stick that in there, the drive blocks drive the head. Oh, sorry, the drive blocks then drive the cutter holder. Unlike a Morse taper, it's not held in by the taper, it's a self-releasing taper, and the drive comes through the dogs that engage there. So I need to make the 2 dogs. They'll need to be hardened, so I'll manufacture those, cut the slots for them, drill them in and tap them, and then harden the blocks that I will make to go in there. But for the moment, that's my spindle drilled and bored. I now need to make the rest of the vertical head. The housings are in place but need welding. The gears are being cut, albeit slowly, but I now have the spindle, or the main spindle. I hope you've enjoyed this quick visit, and I look forward to seeing you in the near future as the project moves forward. Thank you for your time, and thank you for your visit to Dad's Shed.